this is also similar to that of H-trigger register, but it has to sample. Okay, this has to sample during the rise time and also during the fall time. Okay, the input data. Okay, so it samples the input data during the both edge of the clock. That is rise and fall time. Okay, so that by it is possible to design the sequences that samples the input on the both edge. So the advantages of this circuit is, so what is the advantages? So here I can have a lower frequency clock. Yeah. So the lower frequency clock is distributed for the same functional throughput.
And see, maybe to the door to men.
So this will resulting in the, so it will result to power saving. Okay, power saving
Achieve
in the clock distribution network. So it consists of this circuit consists of two parallel master slave based H-trigger registers. And whose output is multiplex using tri-state and drivers. So if this is act as a master, means this one will act as a slave. So you have a this is nothing but a tri-state inverters. Okay. So what will happen when so you can see consider first case,
the signal.
clock is high. Okay, so clock is high. So if the clock is high and clock is high, means these two transistors will conduct and these two transistors will be off, right? So since these two transistors are conducting, the D will reach, the D will be inverted and it will reach the X. So if clock is high, means X is equal to D bar. That is M1 M2 and M3 is on, and M10 and M9 is off. Okay. So this will be act as a master, and this will be act as a master, and this will be a act as a. So this whole thing will be inverter. So the D will not reach the Y. So okay. Since so during this time, the you can see this will be conducting, right? M13 and M12 is on. Okay, M13 and M12 is on, and this M7 and M7 and M6 is off. Okay, and M13 and M12 is on. Okay, since this D will not reach the Y. Okay, will not reach the Y, but the Q value is nothing but Q value is here. Q value is nothing but Y bar. Okay, but we don't know the since the Y is in the high impedance state, there is no use. So this is how the circuit look like when the clock is high. So my X will be equal to D bar. So this X will not reach the Q, and we don't know the value of Y. Okay, but Q value is Y bar now. Okay, so next whenever the clock so during the falling edge of the clock, next one, during the falling edge of the clock. So here the clock values goes to 0. Okay, so if clock is 0 means clock bar is 1. Okay, so which one are conducting? So if clock is 0 means this will be open circuited. Okay, so this will be open circuited. So initially this X value is D bar, no? Then this will be conducting, right? So this will be conducting. Okay. So this will be conducting. So if you see here, since the clock value is 0, this will start conduct. Okay, so this N1 is attached to here. Okay, so you will get now Y is equal to D bar. Okay, so these two transistors will conduct. Okay, so if these two transistors will conduct means so this will be connected to my D. So Y becomes now D bar. Okay, but this clock is equal to 0, no? So this will be open circuited. So this will be open circuited. So now what is my Q? Q value is nothing but D, because it is nothing but X bar. Okay, so my D will reach here. Okay, so during this falling edge, the D value, okay, will reach here, reach at the Q. Okay, so next what I'm going to do, I'm going to make this clock as high. Okay, clock as high. So this so now Q becomes D bar. Okay, so now I'm going for the clock. Again I'm going to make the clock as 1. Okay, So I'm going to see the rising edge of the clock. Okay. So if clock values, if clock is 1 and clock bar is 0. If clock is 1 and clock bar is 0 means this will conduct, right? This will conduct, and this becomes open circuited, right? And this will be open circuited, and this will conduct. Alright, so this will be open circuited, right? So here the D value will reach D bar, and during the falling edge of the clock, whatever the value in the X will reach my Q. Okay. During the rising edge of the clock, whatever the value in the Y will reach my Q. So during the falling edge of the clock also I am getting the output. During the rising edge of the clock also I am getting the output.
Setting.
And you can see the data hence changes on both edges. Okay, so this these latch, okay, these latch will operate. So this latch will operate as if this is a master means this will act as a slave, and vice versa. Okay, so this will operate in the complementary fashion during the each phase of the clock.